All right, welcome to our last unit for 6th grade. We are going to be talking about geology. I'm going to start off with just reviewing the basics of rocks and minerals. So rocks are made up of minerals. Minerals are solid materials on Earth that are occurring naturally, so they're not man-made. They are non-living, and they have an orderly repeating chemical structure. And they have each mineral, so each classified mineral has distinct physical properties. And there are several qualities, 7 that we're going to use to these are 6 qualities that we're going to use to classify minerals. So those are hardness, density, luster, crystal, smell, and color. So color is probably the least helpful property for identifying a mineral because impurities in the soil can actually cause similar, or impurities in the mineral itself can cause minerals of the same type to turn different colors. Then after that, probably smell is the least helpful. There are only certain ones like sulfur-based minerals that have a very identifiable smell, and so we don't use that one quite as much either. So let's talk mostly about hardness, density, luster, and crystal structure. So first of all, hardness, there's a scale for this called the Mohs scale. Diamond, the hardest material, is a 10 at the top. Talc is one of the softest materials, it's a 1 at the bottom. And then we're going to do something called a scratch test to determine the hardness of a mineral. So if you were to take your fingernail and try to scratch a mineral, if you could leave a white line on a mineral, then that would be sort of the mineral failing that scratch test. And so if we had a mineral that scratched with our fingernail, it'd have to be less than a 2.5. If we used a piece of glass to scratch our mineral, and it did scratch, we would say that it is less hard than a 5.5. If we couldn't scratch it, and unless we went and got like let's say a steel file, or if we couldn't scratch it with anything but a piece of diamond, then that could give us information about how hard that mineral is. Density is a trait that is fairly straightforward. It's the amount of matter in a certain amount of volume. So minerals of equal volume, the heavier they get, the more dense they're going to get, and then the lighter of that same volume, the less dense they're going to be. Luster describes how a mineral interacts with the light. So how does it reflect light? We can have a couple of different lusters. So metallic, this one's probably pretty familiar to you. Things that have that metallic shine, like something like aluminum foil, or this rock or this mineral here in this picture, those would have a very shiny metallic appearance. Something that doesn't appear to reflect light at all would be dull. And then we have these other kind of options. There are several different lusters. This doesn't list all of them. You can also have like an oily luster, but this is just a few to kind of give you an idea of what we're talking about. I'm supposed to have a picture here of crystal structure. There are 7 different crystal structures, but they're going to result in different appearances of the minerals. So you can see here that each of these is appearing to break in a different shape. And what that is that's a result of the crystal structure. And so the crystal structure is going to determine how the mineral breaks, how it forms, and what kind of overall shape it has. These are 4 minerals that are found in a rock in Colorado called granite. So we have a lot of granite in Colorado, especially here in the Front Range. Many of the rock formations that you see are going to be made out of granite. So what is granite composed of? Well, it's composed of this pink one, which is called feldspar. This clear one is quartz. Then we have mica, and hornblende is this black one down here. And those 4 minerals are going to combine in to form rocks. So when we combine 2 or more minerals, we put them into a solid mixture, we're going to form a rock. Rocks also have physical properties that classify them. We're going to use some of them the same as minerals, and then others will be different. So hardness and density of rocks are the same as for minerals, but now we're going to add texture, taste, and color. Once again, color is the least helpful property here for the same reason. Different impurities in the rock or different substances that are present can cause rocks in different regions that are actually the same type of rock to get different colors. So we don't want to use color as like our primary identifier for a rock. These four minerals that I was showing you combine to form a rock called granite. And this is something that you probably recognize. This is Horsetooth rock. So Horsetooth is a granite rock formation made out of these four minerals that you see right here. So kind of a cool example. There are three types of rocks that we're going to talk about. This is probably a review for you at some point. You've been over these three types of rocks, so I'm just going to go through them fairly quickly. Igneous rocks are formed from the cooling or crystallization of molten material from the Earth's interior. And so we're going to call that once it flows up to the surface. You might call it lava. Below the surface, you would call it magma. And so igneous rocks that form when they reach the surface of Earth. So if we have the surface of Earth, let's draw it here as a green line, and magma comes up and it boils through. There we go. Okay, it's up here now. Things that form up here, these would be called extrusive rocks. However, if this magma goes over here below the surface of Earth and then it cools down to form a rock, these would be called intrusive rocks. So igneous rocks from below the surface are intrusive. Igneous rocks that form above the surface are called extrusive. You can think this word comes from the same root word as extrude. And the easiest way for me to describe extrude to you is that when you squeeze your toothpaste tube, right, and you squeeze it slowly and the toothpaste begins to be pushed out of the top, you're extruding toothpaste from the tube. This comes from the same root word as intrude. So if you were to burst into your brother or sister's room without knocking and you throw open the door, you would be intruding, you'd be pushing your way in. So intrusive rocks happen when magma pushes its way into the Earth. Extrusive rocks happen when magma gets pushed out of the Earth like toothpaste from a tube. The primary sources of igneous rocks are magma and lava. So once again, I just kind of mentioned this, but magma is molten material beneath the Earth's surface. It contains large amounts of dissolved gas. You can think of this as soda still in the can. So the lid is still on, it's still pressurized, so the little bubbles of carbon dioxide are still dissolved into the magma. Once it comes up to the top, it would be like an open bottle of soda that has been left open for a while and gone flat. So those bubbles escape over time, and there's not very much dissolved gas anymore. So because the magma below the surface has more bubbles than the magma above the surface, or than the lava above the surface, they're going to form two different types of rocks. And so we can look at basically the bubble content or carbonation content of the lava and magma, and we can compare them and know how the rocks were formed and what they were made out of. Here's just a picture of lava flow forming rock. This would be an example. So these are examples of extrusive rocks. These will eventually turn into extrusive rocks. And then this is an example of an intrusive rock, one that might form down here in the rock layers. The second type of rock we have is a sedimentary rock. So sedimentary rocks are formed from sediment or broken up pieces of other rocks. Sedimentary rocks can form from sand, mud, pebbles, and salt, all materials that are found around bodies of water. So bodies of water are going to be really important for the formation of sedimentary rock, because in order for a rock to be formed, a sedimentary rock, other rocks have to be broken. And then they have to be broken into these little tiny pieces called sediment and then buried and compressed. If they don't get buried and compressed, then they just stay as loose sediment. Okay, think like sand or the kind of sludge that's getting washed down a river. Sedimentary rocks are distinct because they can form parallel layers. So when the sediment washes down, we can get layering of sediments. And then if these get compressed and pressurized by being buried, the rocks will form what we call strata, which are little lines in the rock that we can identify. If you drive on the way up to Horsetooth Reservoir, before you get to the granite formation, you can see these really cool layers of sedimentary rocks. And you can see, different layers that have been laid down over time. This is one example of from the drive up there. And so you can see all these different layers. Now, these layers are not pointing horizontally as you might see. So this is showing how kind of the Earth has been changed and shifted over time. We'll talk a little bit more about that when we talk about plate tectonics. I'm not going to get into it at the moment, but just something to notice. And the third type of rock is metamorphic rocks. So metamorphic rocks are any type of rock. So we take a sedimentary rock, an igneous rock, or even a previously formed metamorphic rock, and we subject it to heat and pressure enough to alter it, we're going to get what we would call a metamorphic rock. So metamorphic rocks are oftentimes found between igneous and sedimentary rocks because the heat from the lava changes the mineral properties. So basically, as the lava is over top of it, it's going to change the top layer of the sedimentary rock from the heat and then the pressure of all that new weight pushing down on it. And so we'll often see metamorphic rocks there. Metamorphic rocks you can recognize because they almost look, to me, at least the way I think of it, they look melted. So if you can see, this is a sedimentary rock that then became a metamorphic rock. So the sedimentary layers, instead of looking nice and straight across, look like they got melted kind of and swirled around. And that's what lets us know it's a metamorphic rock. All right, so we're going to move on into geomorphology now, which is a way of talking about how the Earth's surface is formed. So what sort of morpho would be like shapes, and what sort of shapes do we see on the surface of the Earth? Now, there are two ways that the Earth's surface can be changed over time. And so if we generalize a lot to just two processes, we have two basic processes, which are erosion and deposition. So erosion is where rocks or pieces of rocks or sediment are broken down and carried away from a place. Deposition is what happens when those pieces pile up in different places. So to erode means to carry away. If you think of deposit, like depositing something in the bank, you take it there and then you leave it behind. And so these are going to create many different landforms. And I just want to give you guys a couple examples of those landforms here. Today we're only going to talk about erosion landforms. So erosion landforms are going to include canyons, valleys, river channels, arches, cliffs, cirques, ridges, sinkholes, and caverns. I know you guys may not know what those are, so I'm going to walk you through some pictures. And the erosion always has what we would call an agent. So basically an energy source, a motion source, usually that's coming by and causing this erosion. Water is the primary surface of erosion or the primary mechanism of erosion on Earth. And we also have wind, gravity, our climate cycles, so like freezing and thawing and warming are going to affect how landforms are formed. And then chemicals from rain. So sometimes our rain becomes slightly acidic because of carbon dioxide in the air, and it can cause erosion of certain chemical or certain types of things like limestone. So let's just go through a couple of examples of landforms, and I'll kind of tell you a little bit about how they're formed. So arches happen when there is a piece of more resistant rock, so rock that is more resistant to erosion, around and over less resistant rock. So we get these little holes that create arches. Wind is the primary mechanism of erosion for arches, but water can also be very important. Badlands, the primary place you would probably associate this with is South Dakota, but these formations that we see here are primarily caused by water running down and eroding these harder pieces of rock. They are characterized by not having a lot of loose sediment. So these would feel very rocky to climb up. There wouldn't be a lot of loose stuff kind of left on the sides of it. A butte happens when we have a flat top of more dense or erosion resistant rock surrounded on the sides by softer rock. And so water usually flows onto the tabletop of the butte and then over the side. It gets pulled over the sides by gravity, but we get this very flat top with a very steep side. A gorge is formed by water flowing through the bottom, usually think like a river or something, as is a slot canyon, which is formed by pretty rapidly moving water in a place that usually doesn't have a lot of water. And then we also have canyons. So all of these are going to be formed by moving water of some type going through an area repeatedly. Cirques are something that we have pretty commonly in Colorado. You'll notice them by this characteristic U shape here, and that U shape that kind of continues on down through the valley. How this is created is a big glacier sat up here, and as a glacier melts, every year glaciers go through a thaw and refreeze cycle. They don't completely thaw, but the bottom of the glacier will actually thaw and all that water will run down underneath. And as the water runs under the glacier begins to slide downhill. When it slides downhill, or retreats, we would say, it pulls all the rocks underneath it. And as it does that, it erodes this kind of nice U-shaped valley. However, glaciers erode, because they are frozen, they erode this more gentle U shape, whereas liquid water will erode a V shape into the area. So anytime we see that U shape, we want to think ice. If we see a V shape, we want to think water. These two formations, a horn and an arête, form when we have glaciers on multiple sides. So right here, we have a horn, and then on the other side, you can kind of see we have an arête. So a horn is when we have a glacier on three sides, so it's obviously not as common. But you can see these in Colorado quite a bit in the Maroon Bells Peaks. So the Maroon Bells Peaks were well glaciated, and so you see a lot of, or more of these horn formations and these arête formations in those mountains. And so an arête is where you have a glacier on two sides, and so it's going to create a formation that looks kind of more like this. And then a horn has glaciers on three sides, and so we get something that looks a little bit more like a pyramid. This is just another example of that glacial valley. You notice the U shape here. And then this is a hanging valley where basically a steeper slope runs into this glaciated slope here, and so we get a U valley that's higher up. This is a hogback. So a hogback has a more erosion resistant layer, and then covering a bunch of less erosion resistant layers that get washed away. And so it has this kind of characteristic, like the mountain looks different on each side, okay? So one slope is going to look completely different usually from the other slope. These are fairly common in Colorado. We have several up if you drive around Horsetooth Reservoir, if you visit Devil's Backbone, and then further down in southern Colorado, if you visit, well, I guess not southern Colorado, south of us, if you visit Dinosaur National Monument, there is a, if you visit in the Morrison Formation, there's a characteristic hogback that one gets put in textbooks all over the place. It's one of the kind of larger, more famous hogbacks that is around. These are probably my favorite formation, mostly because their name is hilarious. These are called hoodoos. Hoodoos have a tiny little cap of erosion resistant material on top, and so that little cap creates when it rains a water flow that it deflects water, and it creates these little cones. These start out as a ridge, but eventually water wears away all the cap on top, and so this area here gets eroded, but the cap protects the stuff beneath it, so we get these little hoodoos. These form by a similar process as to what we've already talked about, but a sea arch is just something obviously then that is in the water. Yardings, these are probably the runner-up for silliest name after hoodoo. A yarding happens in a desert area where there's a lot of sand blowing around, but the wind blows in a consistent direction, and so as the wind blows in a consistent direction, it erodes these formations, and eventually when it blows over these, it kind of swirls down underneath. And we get these sort of directional hills going here. The next few formations that we're going to talk about are from that acidic rainwater leaching down through the grass and or whatever is on top and eroding away limestone. So we can get sinkholes, we can get bigger sinkholes, we can get gigantic sinkholes. This one's one that happened in Guatemala City. Basically, there's just this giant sinkhole that went about 200 feet deep. And yes, they filled it in, if you're wondering. These gentle sloping mountains that we see in Southeast Asia often, these are what we call karst towers. So this is a limestone-rich landscape that gets slowly eroded over time to form those nice gentle kind of hills. Limestone caves are common when acidic water leaches down into the ground and kind of clears out these formations. And then under the ocean, you can get things called blue holes, where acidic water is kind of going into a limestone-rich landscape and causing these deep holes or caves underwater. All right, we'll pick up with the deposition landforms in the next lecture.